This video will be about subtracting rational numbers. So again, a rational number is an integer, so any whole number plus negative numbers or zero, any fraction, or any decimal that stops. And with our subtracting of rational numbers, you can represent them on the number line just like you could with addition. So the first number still tells you where to start, and then the second number and sign tells you how to move from there. So our first number is 5, so we start at 5. And then minus 8. Minus means move to the left on the number line. So we go 1, 2, 3, 4, 5, 6, 7, 8 steps to the left. So we started at 5, we ended at -3. So 5 minus 8 is -3. The short rule for that is since they have opposite signs, one's a positive, one's a negative, subtract the numbers. 8 minus 5 is 3, and the bigger number 8 is negative, so you keep it a -3. Another example would be -2 minus 4. So we start at -2, and then minus 4 means go left 4 spaces, 3, 4, which takes us to -6. So -2 minus 4 is -6. And since they are the same signs, they're both negatives, we just added 2 plus 4 is 6, but we kept it negative because they were negative numbers. So something else you might see as you're working with your negatives is if you have 2 minuses in a row. We have 3 minus -2. Now when you have 2 minuses right next to each other, together they become one plus sign. So 3 minus -2 is really the same as 3 plus 2, which would give us 5. So we can do our subtraction with fractions again. This is very similar to the addition of rational numbers section. So let's say I have -5 over 12 minus -1 over 10. So first we should take care of the minus. Notice this first negative sign is not coming into consideration over here. It's just because these are directly next to each other. So -5 over 12, then it becomes plus 1 over 10. So next we need a common denominator before we can add or subtract these. So the denominator of the second fraction is 10. That means I multiply top and bottom on the first fraction by 10. So this first fraction would become -50 because 10 times -5 is -50 over 120 because 10 times 12 is 120. The denominator of the first fraction is 12, so we multiply the other fraction, top and bottom, by 12. 1 times 12 is 12. 10 times 12 is 120 again. And it was a positive answer, so now we have a common denominator. That common denominator stays as part of our answer, and we just add the numerators, -50 plus 12. They are opposite signs, so we are going to minus. 50 minus 12 is 38. And then the bigger number was negative, so we get -38. Now we do need to check and see if this will reduce. So we figure out, is there any number that divides into both of these? Well, they're both even. Even numbers end in 2, 4, 6, 8, or 0. And 38 ends in 8, 120 ends in 0. They're both even. That means I can divide both of them by 2. -38 divided by 2 is -19. And 120 divided by 2 is 60. So our final answer is -19 over 60. Because the numerator is smaller than the denominator, 19 is smaller than 60, we don't have to worry about switching it to a mixed number. So that's how we subtract when we're using our fractions. Something else that can change how we work with these is if we have some absolute value bars. Absolute value bars look like ones, basically, but what they're telling you to do is make the number inside positive. If it's already positive, keep it positive. If it's negative, make it positive. So it makes stuff positive. But it only does that after you have it as simplified as it can be inside. So for example, absolute value of 3 minus 8. Even though there's a negative sign inside there right now, we don't worry about it until we've done our subtraction. 3 minus 8 is negative 5. We do that subtraction first. Then we use the absolute value bars, which we know becomes positive. Negative 5 will change to positive 5. The second example, 5 minus negative 2. We know minus minus becomes plus. And 5 plus 2 is 7. Absolute value of positive 7 is still positive 7 because absolute value bars make everything positive. The last thing we can do is work with expressions. So with our letters, say we have negative a plus b, and a is negative 2, b is negative 1. We're going to replace the letters with the numbers we have. Anytime you have a negative, it's a good idea to put it in parentheses when you plug it in. When it's positive, you don't have to put the parentheses in, but since we're plugging in a negative 2, it helps to put in the parentheses. Same thing, since we're plugging in a negative 1, it helps to put it in parentheses. So then we have to simplify. Negative outside a negative is really positive 2. A positive outside a negative is really a minus sign. So we have positive 2 minus 1, which is positive 1. Let's take that same expression, and this time let's say a is 5 and b is negative 4. A is positive this time, a is positive 5, so when I plug it in, this time you don't have to put the parentheses if you don't want. But b is negative, so I'd still put in parentheses around that negative number. So we have negative 5 because there is already a minus sign here. And then, a positive and a negative sign will just change to one negative sign. Since they're the same signs, they're both minus signs, we add 5 and 4 together to get 9. But we keep it negative because they were both negative signs. So that concludes our discussion on subtracting rational numbers.